Assalamu alaikum dear students. We are discussing the functions. Yesterday we discussed the polynomial and the rational function. Today we will be discussing one of the important function, that is signum function. Now a signum function, a function f from R to R defined by f of x is 1 if x is positive, that is it relates positive numbers or the positive real numbers to 1. F of x is 0 if x is 0, that is 0 goes to 0, and f of x is minus 1 if x is less than 0. This means that negative goes to negative. So such a function which relates all positive numbers to 1, all negative numbers to minus 1, and 0 to 0, it is simply called a signum function. Signum function. You know, now what is the domain of this function? Clearly it is defined at each and every, because if x is positive we can say that positive goes to 1. If x is negative we say that negative real number, we say that it goes to minus 1 under this signum function. This means that it is defined at each and every real number, so this means that its domain is simply, or we simply denote this f by s g, and that is signum function. Now what about its range? Range means the image elements. So clearly by the definition it relates all real numbers, whether positive, negatives or zeros, to only three numbers: 1, minus 1 and 0. So this means that its range elements are only 1, 0 and minus 1, hence the range set is 1, 0 and minus 1. So this is the range set. Now how to draw the graph of this signum function? For graph we need two axes. One is the x-axis, which means the domain axis. Now the second one is the range, this codomain axis, which is again a real set. So y-axis. Now all positives go to 1. So this means that if we consider the table, in the first row we consider the domain elements, that x. In second we consider their corresponding image elements, that is the range elements. We know that for 0 it is 0. Now locate this point x0 y0. It is simply the point where these two mutually perpendicular axes intersect. Now the second is when x is 1 means positive, when x is 2 means positive. This 1 2 3 so on to, these are related under this map to only 1, that is 1 1. So we have to locate 1 1 point here, it is 2 1 point here, it is 3 1 point here, because 3 is the domain, 1 is image element. So these are the points. Similarly for negative numbers we have minus 1 minus 1 minus 1 throughout. So locate for these points, locate the points in the third interval as here. Now when we join these such points, it is like this. So here this line in the first quadrant, which is parallel to x-axis, just touches it, does not exactly touch the y-axis, because it just touches the y-axis. Why? Because at 0 we have 0, and if we consider 0 0.1 or 0 0.0001, now this 0 0.001 is positive, and under this signum function this 0 0.001 is 0.001 is mapped or related to 1. So this means that it not touches here, this in the line or the horizontal line in the first or in the third quadrant. It never touches the x-axis, but it is very very close to the y-axis. So this is the required graph of this signum function. Now this another function is the greatest integer function. What is greatest integer function? A function f from R to R, its domain is R, its range, its codomain is R, defined by f of x is this. Here this is called as the greatest integer. Now the greatest integer, it is not greater than the x. It is not greater than the x. That is, this is the integer which is always less or equals to x. What is less or equals to x means that is if f of we consider 2. Now 2, the greatest integer of 2 is, now 2 is itself an integer, so this means that greatest integer of 2 is 2, because this greatest integer should not exceed the given number, that is x should not, greatest integer of x should not exceed the x. Here x means 2 is integer, which implies that greatest integer of 2 is 2. Similarly, if we consider f of 2.1, here 2.1 is not integer, it is simply a rational number. Now what is the greatest integer of 2.1? It is simply 2, because 2 is the integer which is very close to 2.1 but not greater than 1, but not greater than 2.1. If we consider 3, 3 is also an integer. This means that 2.1 is less than 3. So 2.1, greatest integer of 2.1 is not 3, but it is simply 2. If we consider 0.1, now 0.1 is the integer. Or here if we consider 3.1 or 1.99, 1.99, greatest integer of 1.99 is simply 1, because if we consider 2, 1.99 is less than 2, but we have to consider that integer which is not greater than x, it is simply 1, because 1 is always less or equals to 1.99. So how to draw the graph of this? For this we need two axes, one is the x-axis, second one is the y-axis, and for, so clearly for integer values it goes to integer, that is 1 goes to 1, 0 goes to 0 under this greatest integer function, 100 goes to 100, minus 100 goes to 100. But for these decimals, that is from, if we consider here 2.1, it is 2, if we consider 2.9, it is again 2, so the graph is like this. Here if we consider the portion from 0 to 1 on this axis, on the domain axis, 0 to 1, for 0 it is 0, for 0 it is, and for 1 it is here 1, so this means the point is here. But for all the points which are less than 1 and greater or equals to 0, it is 0, so the graph of this is, in this portion is this. Similarly, if we consider 1 to 2 interval, for 1 the value is 1 and for 2 the value is 2. Here for all the points which are in between 1 and 2, the greatest integer is simply 1, because if we consider 2 as the greatest integer of these numbers which lies between 1 and 2, it is not possible, because 2 is greater than these numbers. We have to consider only 1, so this means that all such numbers between this and this, between 1 and 2, are related to 1. This means that the graph is there, this. Here this arrow at 2 indicates that 2 is not mapped, this 1.9, 1.9999 is just mapped to 1, and the number, or simply number which is closer to 2 from left side, they are mapped with 1, it is the only 2 which is mapped with 2. So this means that here from, for this interval 2 to 3 elements, these numbers are related to 2. In this negative interval, here if we consider negative interval -2 and -1, here -2 is less than -1, under -2 is integer, -1 is integer, -2 is related with -2, -1 is related with -1, but all the numbers between -2 and -1 are related with -2, because if we consider -1.9, -1.9 is greater than 2, and -2 is the smallest integer which is very close to -1.9. So this means that here we have this. So clearly its range is simply set of integers, but it is defined at each and every number. Why it is integers? Because there are the gaps between in the graph, that is why this function, the range of this function is simply set of integers. Now here we have the important remark. If we consider function whose domain is set of real numbers, then we say that it is a real function. But if its codomain is also real number, we say that it is real valued function. Real valued means whose codomain or the whose image set is from the set of real numbers. While as if we consider only domain as a real set, then we say that it is a real function. One is the real function, second one is the real valued function. Here in previous functions which we discussed, they are all real valued functions because their domain as well as their range were the set of real numbers. That is why they are called as the real valued function. Now we have the important question. One is find the domain and range of this function f of x equals to root 9 minus x square. Root 9 minus x square. You know that how to find the domain. A domain means we have to find the condition or the restriction on x. Here root of positive is defined, but root of negative is not defined because it is not a real number. We are discussing the real valued functions. If we consider root to be negative, it is complex number. So here f of x equals to root 9 minus x square should imply or is defined only when 9 minus x square is positive. Positive means is non-negative. Non-negative means it may be 0 or it may be greater or equals to 0. So this means that here 9 minus x square is greater or equals to 0. 9 minus x square is 3 square minus x square, that is 3 minus x into 3 plus x, which is greater or equals to 0. So here we have two numbers. One is 3 minus x, second one is 3 plus x. Now the product of two numbers is positive. Now we have two conditions. One, both are positive because positive into positive is positive. That is 3 minus x is greater or equals to 0 and 3 plus x is greater or equals to 0. Here we have and, because if one is positive, second should be positive because their product is positive. So this means that when 3 minus x is greater or equals to 0, in this case, in case first, and 3 plus x is greater or equals to 0, it implies that by transferring variables and constants on one side, it is simply x less or equals to 3 and x greater or equals to minus 3. So in this case we will get this. Or in second case, both the numbers are negative or the product of two numbers is negative, imply because product of two numbers is negative implies that their product is positive, because minus 3 into minus 3 is plus 9. So this means that if product of two numbers is negative, if the two numbers are negative, implies that their product is positive. So these two numbers may be negative, that is 3 minus x is negative or 3 plus x is negative. When 3 minus x is less or equals to 0, negative, and 3 plus x is less or equals 3 plus x is less or equals to 0, implies that x is greater or equals to 3 and x is less or equals to minus 3. Now this x is greater or equals to minus 3 and x is greater or equals to 3 and x is less or equals to minus 3, their intersection is empty because we have to consider that those x's which are greater than 3 and which are less than 3. This is absurd statement because so their intersection is pi. Hence we have to consider only the case first where x is greater or equals to minus 3 and x is less or equals to 3. This simply means the interval, closed interval, minus 3 and plus 3, minus 3 and plus 3. So this is the required domain. In this domain, if we consider x is from minus 3 and 3, this root of 9 minus x square is defined. Now what about range? Now range means we have to find the elements from codomain which are related with the elements from this set, that is minus 3 to 3. Now let y is arbitrarily range element. When y is arbitrarily range element, this means that there exists in the domain, there exists a point which is related with this y, that is, let's assume that this element is x, that is f of x is y. Now f of x is defined as root 9 minus x square equals to y, or which implies that in this case y is here root of something, root of 9 minus x square. Root is always positive, which implies that y is positive. It is actually non-negative. Non-negative means which is never negative. It may be 0 or this positive. So this means that y is greater or equals to 0. It is the first condition for y. Now the second one is here root of 9 minus x square equals to y. In this, by squaring we get 9 minus x square is y square, or 9 minus y square equals to x square. But square of any real number is positive, which implies that 9 minus y square is greater or equals to 0. 9 minus y square is greater or equals to 0. In the domain, we have 9 minus x square is always positive. When 9 minus x square is positive, we get x belongs to minus 3 to 3, open closed interval minus 3 to 3. But here we have the same situation. 9 minus y square is greater or equals to 0, which implies that by the same procedure as we followed, or as we discussed in the domains condition, y belongs to interval minus 3 to 3, minus 3 to 3. But here y is positive, which implies that y is positive means y belongs to, we have to consider only the positive values from this minus 3 to 3. Hence y belongs to 0 to 3. So the range is 0 to 3, which implies that this is the function whose domain is interval minus 3 to 3 closed interval, but its range is 0 to 3. You can check this by putting the endpoints of these intervals. So thank you.